It's been discovered that there are a lot of weird and unusual things happening on Jupiter that we didn't know. About the first infrared images from the James Webb Space Telescope were studied, and new structures have been found within Jupiter's iconic Great Red Spot. Storm so massive and powerful its winds move at speeds of 270 to 425 mph 3.5 times faster than a powerful F4 tornado, and big enough to engulf our entire planet at once. Jupiter's Great Red Spot is a massive storm that's been swirling for centuries, but lately it's been found that this enormous storm isn't as stable as it once seemed. It's wobbling, almost shaking, and its size has been fluctuating in ways that are pretty surprising. The Great Red Spot is shrinking. It used to stretch over 24,000 mi across, but now it's down to about 10,000 mi. But here's the twist. It's not just steadily getting smaller. The storm has been expanding and contracting almost like it's breathing, and it's not exactly clear why. The wobbling motion is fascinating. Might have something to do with the wild jet streams and turbulent swirling around it. Jupiter's atmosphere is chaotic, and all that energy could be nudging and pulling the storm in different directions. On top of that, Jupiter generates a ton of internal heat, which could also be affecting how the storm behaves. Not too long ago, there was even a moment where pieces of the storm looked like they were breaking off and drifting away. That had some people wondering if the Great Red Spot was being torn apart. But here's the thing. This storm is powered by an insane amount of energy, so it's not going anywhere anytime soon. It might change shape or size, but it's likely to stick around for decades, maybe even centuries. The Great Red Spot's recent wobbling and size changes are just another reminder of how dynamic and unpredictable Jupiter is, and the new images we're starting to see are uncovering all kinds of mysteries about the gas giant. Citizen scientist Judy Schmidt of Modesto, California, processed these images of Jupiter using data from the James Webb Space Telescope to further enhance the original photos. The results were breathtaking. You can clearly see the auroras, and in another image, a tiny debris ring and a few moons around the gas giant. The clarity of these images has allowed us to study Jupiter's dynamics in ways never before possible. Jupiter's upper atmosphere acts as a boundary between the planet's strong magnetic field and the different layers of atmosphere. Below, at the poles, the spectacular auroras are fueled by volcanic material ejected from Io, one of Jupiter's moons, which we'll talk a bit more about in a moment. Closer to the equator, the atmosphere is shaped by sunlight. Since Jupiter only receives about 4% of the sunlight that Earth gets, it was long assumed that this region would appear mostly uniform, but in July 2022, Webb's near-infrared spectrograph observed Jupiter using its advanced integral field unit to study the area above the Great Red Spot. The goal was to see if this region was as uneventful as everyone predicted. Instead, the observations revealed a surprising variety of features: dark arcs and bright spots spread across the area. The blue areas in the image are at a much lower altitude than the areas in red, showing that this storm has an interesting structure. While sunlight influences the light from this region, it was found that another mechanism may be at play, altering the atmosphere structure. One explanation involves gravity waves similar to ripples caused by waves crashing on a beach. These waves, which originate deep in Jupiter's turbulent lower atmosphere, travel upwards and shape the structure and emissions of the upper atmosphere. Interestingly, these kinds of waves are occasionally seen on Earth, but are far weaker than what we've observed on Jupiter. But something else was discovered: a new Nave seen feature in Jupiter's atmosphere, the big white band of clouds at the planet's equator that is more than 3,000 mi wide and sits above the planet's main cloud peaks, was discovered to be moving across the planet at 320 miles per hour. That's way stronger than even the most powerful storms on Earth. But not only is the James Webb Space Telescope getting some amazing images of Jupiter, let's not forget that the Juno probe traveled an astounding 1.7 billion miles and is still carrying out its Jupiter mission to study the planet. On its 66th flyby of the gas giant, it grabbed some new images of the planet and a couple of Jupiter's moons that are simply stunning, using raw image data that's available online to the public. Citizen scientists enhance the contrast of the visible light images to highlight the planet's remarkable range of colors, and striking visual complexity, and unveiling the intricate dynamics of Jupiter's stormy atmosphere, vivid and powerful bands, swirling cloud formations and vortices, such as cyclones and hurricanes of varying sizes and intensities. In many of these images you can see a series of small cyclonic storms that seem to be interconnected. In fact, these storms seem to form a kind of atmospheric network, suggesting that Jupiter's atmosphere is far more interconnected and complex than many thought. Jupiter is full of mystery, but the planet also has 79 moons, and the biggest of them is Ganem or Jupiter. 3 in this Hubble Space Telescope image, you can see just how big this moon is. Ganem orbits about 666,000 mi away from Jupiter, and it's interesting for many reasons. The Juno probe is still out there studying Jupiter and its moons. It recently grabbed some new images of Ganem. It was the first time in 20 years that the moon had been seen again in photos, and something surprising was found. This time images were looked over, and evidence was found showing Jupiter's big moon may have been hit by an asteroid, nearly 93 meters wide about 4 billion years ago. That's a huge space rock, some 10 to 15 times larger than the Chil-Love meteor that hit Earth 66 million years ago. The impact of this mega asteroid was so powerful that it knocked Ganem off its axis and altered its rotation. One interesting thing discovered was that most of the material ejected from the collision fell back into the crater, leaving it mostly hidden. Despite this, the evidence for this massive impact can be seen in the moon's surface. Ganem is actually full of craters, and some of them are very large, showing that this moon has been hit by more than just one massive ancient asteroid in its past. But Ganem could possibly be hiding something else, and maybe a whole lot more. Just recently, it was discovered that there is water vapor in the thin atmosphere of Ganem, located 500 million miles from the Sun. The water ice on its surface is frozen solid in frigid temperatures as low as 300 degrees F. This makes the icy surface of the moon as hard as rock, but a rain of charged particles from the Sun is still enough to turn the ice into water vapor on Gim. And while it may look like any ordinary barren iceball moon, some believe that beneath the icy crust lies a vast ocean of liquid water. If so, this ocean could be home to life, or it could give us some clues about the conditions necessary for life to emerge. New missions are planned to find out what's down there. Another of Jupiter's incredibly fascinating moons is Io, and this moon does a lot more than just quietly orbit the planet. And this brings us to auroras. Here on Earth, the auroras we see are totally different from those on Jupiter, since they're caused by charged particles from the Sun hitting the Earth's atmosphere. But since Jupiter is much farther from the Sun, no one understood what was powering this planet's auroras. Juno did a flyby around both of the planet's poles, and the probe's instruments detected electrons in Jupiter's atmosphere being propelled toward the planet with energies as high as 400,000 electron volts, an astonishing 30 times more powerful than the strongest auroral potentials recorded on Earth. This time-lapse image also captures a unique phenomenon: emissions linked to the magnetic footprints of 3 of Jupiter's largest moons. These footprints trace the path of Jupiter's magnetic field from each moon down to the planet's surface. These glowing emissions are created by electric currents generated by the moons, which travel along Jupiter's magnetic field and interact with its upper atmosphere. This is important to know, and you'll see why in a minute. Io is covered by lava lakes and more than 400 active volcanoes, which constantly spew out volcanic material into Jupiter's magnetosphere. This Juno probe captured 2 plumes from active volcanoes on the moon in this image, and just recently, in new Juno data, a huge volcano was seen erupting. Along with all the new image data and combining data from the Juno probe's instruments, it was found that every 27 minutes Jupiter produces a burst of X-rays. Now, it was only a matter of looking at the Juno data to see what other things were also happening every 27 minutes. And this is what was found. When Jupiter rotates, it drags around its magnetic field, which is then struck directly by particles of solar wind, and compressed. This compression heats the electrically charged atoms called ions that are trapped in Jupiter's magnetic field. This triggers a phenomenon called electromagnetic ion cyclotron. Waves guided by Jupiter's magnetic field, the ions surf the emic wave.